most of our questions will be speed questions. I might have to rearrange my equation. This is a triangle thing. Let's say I want to isolate d in here. What would d equal? V times t. Okay, so rearrange, I'm going to say d equals v times t. Going the other way, what does t equal, please? D over v. Okay. Now, how I got that is, I want to get time by itself here, right? So the v I just need to divide by. We will be dealing with a lot of speed problems. The reason why these equations are difficult, and we're actually in grade 11 for these word problems, is that we're actually solving for two things at once. Okay, which is what makes it difficult. All right. There are two unknowns in each equation, and I'll show you what I mean right now. All right. Example 1. Says Andrew and Callan I'm going to spell this wrong. Yep. Good. Can row 8 kilometers per hour in still water. Okay, what the heaven does that mean? What does still water mean? Anyone here a canoeist? Anyone canoes?
No resistance.
No resistance. Okay, so you drop these guys in a pond. There's ducks keep going around, but there's no actually motion. They can go 8 kilometers an hour. That's how fast they can paddle. We're going to say it takes them it takes them 16 hours to row 39 kilometers down a river. And 39 kilometers up a river. Find the speed of the current to 2 decimal places. Yes, you guys are extensive paddlers. Okay, 16 hours straight. What I'm saying is, this is what's going to happen. I'm going to just do a little demonstration. I apologize to the internet because you cannot see this. Okay, so these guys are paddling away. If the river is going in this direction, when the gentlemen are paddling like this, will they be going faster or slower than 8 kilometers an hour? They'll be going faster, right? Then all of a sudden they have their lunch, they take a little break, say, oh, thank goodness that was over. They turn around. The river's still going this way. Will they be going faster or slower than 8 kilometers this way? Slow. Okay. That's what makes this question more difficult. Okay, because you'll be going different speeds in one direction compared to the other direction. You see the problem we're having here? Okay. So that's what we're going to look for here. Right. So we're just going to make a quick little list here of all the things that we know. Can I get just volunteers? You only have to raise your hand once. Tell me something from the equation that we know. Go ahead. Yeah, so the total time is going to be 16 hours. Okay? I'm going to put a few question marks in there. I'm not going to put variables in there yet. What else do we not know? Or what else do we know? What else do we not know? Tell me something else with this equation. Guy, go ahead.
We know like the total distance.
Yeah. Yes. I'm going to say the distance upstream is 16. 39 is right here. And the distance downstream is 39. Okay. Now, one other thing I'm going to put in here, okay, because this is the aha moment for all of these questions. Math teachers are all the same. We are all writing our questions all the same. What I will do, and I haven't done this whole thing, this is our first word problem we did this year. Here's, I'm gonna tell you Sadler's 3 steps to a good word problem. Step number 1 is draw a picture. You can't really draw a picture for here. You sort of can if you want to. Draw 2 guys in a canoe paddling left and right. If that helps you, go ahead. Okay. Second thing though is read the question twice and then read the last sentence a third time. What does the last, if you're in my grade 9 class, you should remember this. What is the last sentence always going to tell you in a math question? What you have to find, right? So what are we looking for in this question? The speed of the current. So I'm going to right away say let x equals the speed of the current. Okay. So far so good? What else do we know? There's one other thing we haven't used yet. What's the other thing we haven't used? You guys stay with me, the 8, okay? So here's the thing that you gotta get. What is the boys, man, what should I call you guys? Let's just say speed. What's their speed upstream? So if they're paddling against the current, what is their speed going to be? If they're going against the current.
Below 8.
Below 8. So how much below 8?
From 1 to
Careful, careful. How much below 8? So we're going to say it's going to be x. Whatever the stream is, right? You want to subtract it from the 8. What's their speed going to be with the current? So we knew here. What's the speed going to be with the current? Plus it. Okay. Okay. So all I'm trying to do here is sort of list out all my givens. That's all I'm basically doing. Okay, so I have my total time is 16, my time upstream, my time downstream, my distance, my speed, and all sorts of things. Okay? The way I'm going to do this is I'm going to use that V equals D over T thing, if I can. All right. What I'm going to say is, though, because I was given the total time, and I don't know how much the time upstream and time downstream is, I'm going to make an equation that says total time equals time upstream plus time downstream. Okay, going back to the top of your page, what is time equal to? Oh yeah, so no, we're just in general. What's like from physics class? What's time equals? T equals what? Distance over velocity. So, what is the distance upstream going to be? Oh goodness. 39, wonderful. What's their time upstream going to be? Yeah, this is speed, yeah, 8 minus x. That's going to be plus 39 over 8 plus x. What's my restrictions on x, please? -8 and 8. Now, why does that make sense? Why can you not have a river going 8 kilometers an hour? Okay, well, I'll tell you. I'm paddling at 8 kilometers an hour. If the river's going 8 kilometers an hour, what's happening? I'm never going to make it, okay? I'm actually going to probably even put a better domain here if I want to. What are the possible values for the speed of the river going to be from what to what? What are the, no, we're never done domain. What are the possible values for the speed of the river going to be? Well, what's the smallest value? What's the smallest speed of the river can go? 0. Yeah, 0 to 8, we're going to say. So usually 0 to 7. I'm going to use decimal and say 0 is less than or equal to x is less than or equal, which is less than 8. These are going to be for us suitable limits, okay? Because if you think of the speed of your river, you can't have a negative speed, okay, for a river, like the river is going to be going, okay? 0 is the smallest, and then if it's going 8 or bigger, you're not actually going to get any motion, right? So it doesn't make, it's impossible for these guys to actually go any place if there's like a 10-kilometer river, right? They wouldn't go any place. All right, let's do some algebra here right now. Can I get someone who's not raised their hand in a while? Who's the person who said they want to do everything in one step? Callan, that was you. Callan, can you be brave and solve for x? What do we do?
So you take both of them out at the same time.
Okay, go ahead.
So it'd be 16 bracket x minus 8
Yeah,
bracket 8 plus x.
yeah,
And then was 39
yeah.
bracket 8 plus x
Yeah.
plus 39 bracket 8 minus x.
Do I need to show how we got that? That's wonderful, by the way. Do I need to show where that came from? Or are we okay? We've done enough of these yesterday. Do I need to show that? No, nobody's talking, so we're okay where that came from? Yes, good. All right, I'm gonna hit pause and you guys are gonna solve for x. Like the